Bienvenidos, Ushamdi, and welcome to this HUT8 networking techtorial on MPLS Layer 3 VPNs. This is part 3 in a 7-part series called the Director's Cut, where I have consolidated, condensed, and polished up a 3-part series that I had done 4 years ago on MPLS Layer 3 VPNs. And this is a thank you to all of you viewers who have put me over 1 million views just at the end of last year. So in order to say thank you, I've taken the most popular videos out of the MPLS L3 VPN series I did 4 years ago and completely redone them, and hopefully have provided you with a much better learning experience. I've broken things down into a little more digestible chunks, all 20 minutes or shorter, and this is all going to be about virtual routing and forwarding. So in part 1, we did our OSPF configuration in the service provider core. In part 2, we took a look at the label distribution protocol, and we dove in and saw just what LDP or MPLS is actually doing in the service provider core. Now we're going to get onto our provider edge routers and do our VRF configuration. So you might notice that we haven't done a whole lot on the customer side. And this is one of the things that makes MPLS and MPLS Layer 3 VPNs specifically such a killer application from a service provider perspective, is that all of the heavy lifting is on the service provider side of the equation. The customer is simply going to be connecting in, and then things are going to work auto-magically. But it's on the service provider side where we've got a lot of work to do. So what are VRFs and what is virtual routing and forwarding? Well, let's go ahead and take a look at our diagram. I've added in an image here up on the sort of top right-hand side here that shows a router that's been logically divided up. So the analogy that I like to use is VMware, and the analogy holds up to a certain point, and I'll talk about where we diverge with this analogy. So the PE router, PE1 and PE2 in our design, we can actually use Cisco iOS software to create virtual routing and forwarding instances. Again, I want you to think of them as like VMs. So just like on a physical host machine, if I install the VMware software, I can then spin up virtual machines that are mutually exclusive from other virtual machines and from the host OS. On a router, it's much the same thing. I've got Cisco iOS loaded on my physical router, and in Cisco iOS, just like you would spin up a VM on VMware, I can go ahead and spin up a virtual routing and forwarding instance, or a VRF, a VRF. And it's going to give me my own Ceph table. It's going to give me my own routing table. So I get my own RIB, I get my own FIB. Now, this is where it kind of diverges. On the Cisco side of the house with VRFs, when I'm configuring VRFs, I'm actually sharing all of the resources on that router. And there's no way for me to say, well, give 8 gigs of memory to VRF A, but only give 2 gigs of memory to VRF B. Where with VMware, you've got a little more flexibility with what you can do. So again, the analogy works well from a theoretical perspective. From an operational perspective, it's going to start to slow down and taper off a little bit. But again, I'm hoping that the image gives you an understanding that all we're doing is carving the physical router up and creating a bunch of individual instances of, call them mini routers, right? Or virtual routers. And I always have my global table. And that global table is going to be how I'm doing my communication and my OSPF routing down here in the service provider core. Right? Has nothing to do with the customers, but I need to carve out some virtual routers and forwarding instances for the customers. So let's go ahead and dive into the command line and see how that happens. And then we're going to come back and talk about route distinguishers, right? We've got 2 down here, some good examples. And then we're going to talk about route targets. And these sometimes can become a little confusing for learners in terms of what it is they're really doing and which one's part of BGP and which one's not part of BGP. So let's jump on to the command line. So here we are again back on R3P1. Now, I need to create a VRF, a virtual routing and forwarding instance, for each of my customers. Remember, for each customer VPN or for each customer that's connected, I'm going to have a VRF because I want to keep them separated. I don't want their routing information in my global routing table. Remember, that global routing table on the provider side is going to be used internally for the OSPF that we're doing and those loopback addresses that we're reaching. The last thing we want is for customers to see our information internally or for us to see their routing information internally, because there's no way we could guarantee uniqueness. So, and we'll talk about that uniqueness in just a second. So we're going to go from user exec to privilege exec. I'm going to get into global config. Now, the old school way to create a VRF would be to say IP VRF, and then you could give the name. But again, this is kind of the old school way to do it. Just like when you say show IP BGP summary. That's sort of the old school way to do it. And when I say old school, I want you to think address families, because address families is the new cool way to do things. So I would say VRF definition, and I'm just going to use the customer name. So I'm going to say customer A. Now, when I get here, I'm going to create what's called a route distinguisher. And here's what the route distinguisher is, and here's what it does. If I pull the image back up, excuse me, you can see that the route distinguisher is nothing more than a 64-bit value. And that 64-bit value is the autonomous system number, colon, and then some arbitrary number. I could put the IP address and some arbitrary number in there. But again, it's 64 bits. So you might be asking, well, why in the VRF table do we need a route distinguisher? And this is extremely important. Remember, the route distinguisher is not a BGP extended community. Okay, the route distinguisher is not a BGP extended community, and it has nothing to do with VRF membership or VPN membership. It doesn't dictate which VPN, when I get to the other side, I'm going to be placed into, right? Has nothing to do with that. So when we talk about the route distinguisher, it has one purpose and one purpose only, and that purpose is to simply differentiate and make unique the customer prefixes that this PE router will be communicating to this PE router and vice versa over multi-protocol IBGP. Again, the route distinguisher does nothing except differentiate and make unique the customer prefixes as they get communicated over multi-protocol IBGP. So think of it like this. If router 1, over here, customer A, had a 192.168.1.0/24, and they advertised that to router 3, and router 2 had a 192.168.1.0/24, and they advertised it to router 3, when that BGP update goes across the service provider core, how is router 5, PE2, how is it going to differentiate between which route goes to which customer? It has no idea. And so we're going to talk about the route target here in a second. So the route distinguisher makes unique and differentiates the customer prefixes. That's all it does. It is not a BGP extended community, and it has nothing to do with VRF membership. It's once we place something into the VRF membership that it will then make its way to the right customer. All right, so back to creating our VRF. So I'm going to say definition, customer A, route distinguisher. And if I do a question mark, you'll see the multiple options we have here. I can do an ASN, I can do the IP v4 address, or you can do the 4BASN. Again, we're going to go ahead and I'm going to keep it very, very simple. So customer A is the first letter in the alphabet. We're going to say the route distinguisher is 1:1, right? Now, I need to get into the address family. If I do a question mark here, you can see I could put a description, but I could also go into the address family for IPv4. We're going to be doing the same thing with BGP. We're going to have a VPN v4 address family, and then we're going to have some IPv4 VRF address families. So it's very, very similar. Now, once I'm in here, this is where the route target comes into play. Now, The route target, unlike the route distinguisher, the route target is an extended BGP extended community. And it is going to dictate VPN membership, right? So the route target is a BGP extended community attribute, and it dictates the VRF or the VPN in which we belong. So I'm going to go ahead and say route target. And if I do a question mark, we can say both, or I can put the value in. So I'm going to say both, but this allows me to put the value in now. And so here's what we'll do. We're going to use the PE routers, what will be the BGP router ID, because we know this router by 3333. And then I'm going to say colon. And since we're talking about customer A, I'm going to say 3333 colon 1. So I'm going to use an IP address and then that arbitrary number. That is going to be the route target that I export as well as look to import for customer A. All right, well, let's jump out of here. And then we're going to do the same thing. I'm going to say VRF definition, and we're going to say customer Z. Now, customer Z, Z being the 26th letter in the alphabet, we'll use 26 colon 26. Again, address family IPv4, and then we're going to say route target, both, and I'll use 3333 colon. Now, I can't use colon 1 because then what am I saying here? Yeah, I'm saying that then customer A and customer Z, that they've got the same route targets, right? And we don't want that because this, remember, the route target is what makes unique the customer VRF and the customer VPN. So I'm going to say 26. And again, these are simply values that I'm using. There are many, many other ways you could go about identifying the route target. So we've created the VRFs for customer A and customer B. Let's go ahead and say N, and let me say show VRF detail. Now this is a great command. It's going to show me a lot of information, and you can see it gives me the VRF ID, and it looks like we're going to go up in numerical order, right? ID 1, ID 2. We've got the route distinguisher, and we also have the export VPN route target and the import VPN route target. Again, very important because this is how we're going to get the routes, and this is how we're going to send the routes in BGP. Excuse me. All right, we've got no route maps or anything like that, so that's one good command. Another one I like is show run VRF. This is a nice consolidated command here. Gives me the stanza for the VRFs that are configured, so I can really quickly take a look and see, okay, great, so this is how things are set up. And then I can say just show VRF is another great command, right? Even more consolidated here, shows me my route distinguishers, right? I don't see my route targets and no interfaces yet, but that's about to change. So let's go over to provider edge router 2, router 5, and let's do the same thing over here. We're going to go from user exec to privilege exec into global config, and I'm going to say VRF definition, customer A. The route distinguisher, I'm going to go ahead and use the same one I used before, and this is, this is okay, right? Then we're going to say address family IPv4, and we're going to go ahead and set the route target both, and remember, I'm importing and exporting 3333 colon 1, so 333 colon 1. I'm going to send the routes and receive the routes that are part of that BGP extended community, which dictates VPN membership on the customer side of the house. And then I'll just pop out here real quick and we'll say VRF definition customer Z, and his route distinguisher is 26 colon 26. Address family for IPv4, because if I had IPv6, I could do the same thing, right? And that's why we don't use IPVRF anymore. And you're probably using VRF definition because you might be doing IPv6. So what did I say here? So then we're going to say route target, and the route target is going to be for both 33. Oh, you know what? I just realized I put 3333 in there. So let's go ahead and we'll keep it 3333 colon 26, right? So I'm using the IP address of the PE1 router here on both sides. And what I could do to clean this up is I could pull those statements out and export and let's do that actually. Let's clean this up a little bit. So I'm going to exit out here for a second, and we're going to say no here. Let's just clean this up. So we're going to say, whoops, didn't want to do that. Control A. So we're going to say no route target, and so we're going to say route target, And we're going to export the 5555:26, and I'm going to import, and let's say import 333:26. This is going to look much nicer. So we'll pull this out, and I'm going to go back into VRF definition, customer A, and address family IPv4, address family IPv4, and we're going to say no, and we're going to pull that out for the statement there. And I'm going to say route target import, and we're going to import 3333:1 because that's what we're going to be exporting on the other side. But then we're going to go ahead and we're going to export 5555:1. And let's say do show run VRF, and let me make sure we've got everything cleaned up. So much nicer, right? And again, kind of winging this here, so didn't think this all the way through, but this looks great. So we're exporting 555:1 from router 5, and we're importing 3333:1 from router 3. And the same thing here for customer Z. Now let's clean up over here on this side. So we'll get back into global config, and this is what I like to call the bonus lab, customer A, and we're going to say address family IPv4, but it's an easy fix. We're going to say no route target, and both for 3333:1, and we're going to say route target is going to be import. So now I want to import what's being sent over from the other side. So I want to import 5555:1, and I'm going to export, because the other side is importing, so I'm going to export 3333:1. And then let's bail out of here, and let's go into VRF definition for customer Z. And we're going to say address family IPv4, and how about no route target both 3333:26, and we'll say route target, and we're going to import. Now remember, what am I going to get from the other side in terms of that BGP extended community that defines VRF membership and VPN membership? We're going to say 5555:26, and the other side is expecting to see on its import statement, the other side has 3333, so we need to make sure we're exporting 3333:26. All right, let's take a look at the show run VRF. Right, it looks good. If I say show VRF, everything looks great here. Now, we've created the VRFs, but the question now becomes, what do we do with them? Well, remember, we said that these are a customer-facing entity, and I need one for each customer VPN and each customer connection that comes into this router. So if we look back over here at our diagram, we can see that PE1 and PE2 have two connections, customer A and customer Z. So let's find out what interfaces those guys are on. We'll say show IP interface brief, and we're simply going to go activate or place the VRF, or place the interface into the VRF that we've just configured. Now, it looks like here on PE1, router 1 is going to be, we'll go into global config interface gigabit Ethernet 01. Now, this is something that I used to scratch my head as to why the Cisco iOS would do this. So I'm going to do something. I'm going to say do show IP route. This is my global routing table. And you'll notice that in the global routing table, I have directly connected information here, right? Administrative distance 0 for that directly connected information. So I've got directly connected interfaces in the global routing table. Remember what I said? When I put an interface into a VRF, it's going to go into like its own little hermetically sealed bubble. And inside that bubble, it's going to have its own rib. It's going to have its own Ceph table, completely separate from the global routing table and the global Ceph table. So, or say Ceph database. So here we see the global routing table. So now let's go ahead and say VRF forwarding customer A. Now, what's about to happen is, this is what I was alluding to. When you hit enter, it takes the IP address off the interface. So if you didn't have that information stored away somewhere, or couldn't access it real easily, or didn't have it memorized, you would kind of be stuck right now. You could reload the router to find out, not save the config and reload the router and get the information that way. But it removes it because it's placing it into a VRF. It has to remove the addressing information because it's pulling it out of the global routing table because now it is no longer in the global routing table. Now, it would be nice if Cisco, because it knows I'm pulling it off this interface, why not place it back in or place it into the VRF, but then just put my IP address back on there? There's got to be an easy way on iOS that they could, probably 2 lines of code to make that happen, right? So, but we don't get that done auto-magically. So now I'm going to have to say IP address 198.51.13.3 is my IP address, and it was a /24. So now I put my IP address back on here. So let me go ahead and take care of do show IP interface brief. Let's take care of interface gigabit 02, and we're simply going to say VRF forwarding for customer Z. And again, the IP comes off that interface because it's removed from the global routing table and placed into the VRF that we just created for customer Z. So I need to put my IP address back on here, 198.51.23.3, and I can see that IP right there, so nice and convenient. And now we should be good to go, right? So now what happens if I try to ping over to customer 1? And this is not going to work, right? So why is that not going to work? Exactly, it's not going to work because we've placed the interface to customer 1 into a VRF. So I would have to say ping VRF customer A and then customer A's IP address. And now after an ARP, there we go, we missed a packet at the beginning, a ping packet at the beginning, but now it's working. So I've got to refer to it with the VRF now because remember, it's in its own hermetically sealed little bubble from a Ceph and a RIB perspective. So if I say ping 198.51.23.2, it's not going to work. So for me to fix this, I would have to reference the VRF. So let's go ahead and we'll let this time out on its own here. And then we're going to say ping VRF customer Z and 198.51.23.2. It should ARP. We might miss one, and there we go. And now we've got full connectivity. So what happens if I say show IP route now? Show IP route. Yeah, what happened to those 198.51s from the global routing table? They're gone. So what do I have to say? Do I say show VRF customer A IP route? Whoops, typoed that. And this is not going to work, by the way. So no, it's not that. It's going to be show IP route. So unlike the ping command where the VRF came up front, I say show IP route VRF customer A, right? So, and that can be a tough, flipping back and forth between the ping and the show IP route because the order of where the VRF command comes in gets changed. So, but again, there's customer A and customer Z. So take a look at that, right? Absolutely beautiful. All right, so let's finish things up here with the VRF piece. I've got my VRFs here. Let's go ahead and say do show IP interface brief. And let's see what interfaces we need to manipulate here. And it's going to be interface gigabit 05. And I'm going to say VRF forwarding for customer A. And remember, the address is taken away. So I say IP address 198.51.56.5, and it's a /24. And let's test. Do ping VRF customer, what am I saying here? VRF customer A, and then my IP 198.51.56. I've got the other IPs in my head right now. .6 is what I believe it is. Oh, I'm sorry. Customer A, I hit Z. Apologize. There we go. So we should have an ARP, and then everything should be good, and it is. Let's get an interface gigabit Ethernet 06. Apply the VRF to the interface and basically pull the interface into the VRF. So VRF definition, or sorry, forwarding for customer Z. I'm getting my customers mixed up here already. Customer Z, right? We lose our IP address 198.51.57.6. Gotta be careful. 57.5, 57.5, 255.255.0. And let's fix that first. I apologize. I'm trying to keep us under do ping VRF customer Z, trying to keep us under that 20-minute mark here as close as I can get us. And can I ping customer Z? Absolutely. Do show VRF. Right now we have interfaces that show up here. What address families, right? Just IPv4, that's it. So we are all set up. Our VRFs are now configured. And here are some good commands that you can use to set the VRF up, to apply the VRF on the interface, and then to confirm how the VRF or what the VRF looks like in your configuration with show run VRF, show VRF detail, right? So that is wrapping up part 3 of this Director's Cut series on MPLS L3 VPN. Again, thank you guys so much for watching. I hope you enjoyed this. Now we're on to the big kahuna, multi-protocol BGP. Thanks for watching, and I'll see you in the next video.